Hi guys, section 3.2 notes. Again, lots of stuff to graph in this chapter, so hopefully you have 3.2 on a handout. Ask for one if you don't, so then you don't have to write down all these words. The instructions should already be there, and so should the graphs. Tell whether the point 3, 4 is a solution of 3x minus y equals 7. Mine is nice and color-coded on my smartboard. Yours isn't on the printout. But it's reminding you that these go in order of x, comma, y, and it wants to know if it's a solution, or sometimes it actually says, is it on the graph of 3x minus y equals 7. So all we have to do is take 3 times x, which is 3, minus y, which is 4. 3 times 3 minus 4. Hit that on your calculator. Don't do it in your head. 3 times 3 minus 4. You get 5 equals 7. No, it's not a solution. That's all it's asking for. Did you put x and y in the right spot, and did you calculate it with a calculator or with order of operations? Tell whether 4 negative 1/2 is a solution of x plus 2y equals 5. So we put in 4 plus 2 times y, which is negative 1/2. See what it equals? 4 times 2, 4 plus 2 times negative 1/2 is 3. 3 equals 5. Nope, not a solution. Neither one of those are solutions. Tell whether negative 2, 3 is a solution of 2y minus x. Don't fall for it. They're trying to trick you. They're putting the y first instead of the x. You won't fall for it. 2 times y, which is 3, minus, they're trying to doubly trick you. They wanted you to minus the x, but the x already is negative. 2 times 3 minus negative 2. See what that equals. Type it in. 2 times 3 minus a negative 2, or in your mind you might know that that's a plus, and you get 8, which does indeed equal 8. So you answer this one as yes. It is a solution, meaning it worked. It's just like when we solve equations and you check your answer. You're plugging in the x, plugging in the y at the same time now. Just got to plug them both in the right spot. A little more graphing, but this says graph the function. We have to solve the equation for y first. Let me cover up all this. We don't want to look at it yet. Solve the equation for y first. We can't graph this and set up the table until that negative 2x is over there on that side of the equation. So how are we going to do that? We're going to take negative 2x and add 2x underneath it. If we add 2x, it gets rid of it. We know that from the solving equations. We also know whatever you do to one side of the equation, you must also do to the other side of the equation. So if we add 2x on the left there, we add 2x over there. This is a review. Remember, we did this in section 2.8. Y equals, and we're going to put the x first, 2x minus 3. Can't combine them. They're not like terms. The 2x goes first, then the minus 3. Now we have a table, and we want to put our domain in there. Because there's no fraction, we can go with our usual negative 2, negative 1, 0, 1, and 2. Go ahead, pause the video. Let's fill this out and come up with 5 ordered pairs here before we do any graphing. All right, pause it. Okay, you should have your chart all the way filled out and your 5 points that you're going to graph. Make sure you go the correct direction when you graph this. This is going left 2 because that's x, down 7 because it's negative and it's y, left 2, 1, 2, down 1, 2, 3, 4, 5. That's a little bit too far. We don't even have to put that one on the graph because it's too low. How about -1, -5? Let's see if that fits. left 1, down 1, 2, 3, 4, 5. Got it. Next one is at 0, -3, 1, 2, 3. The next one is at 1, -1, so you're going over 1, down 1. Next one is at 2 and 0. Nope, it's at 2 and 1. See, I could tell it was going in the wrong direction. Over 2, up 1. And we only have 4 points on the graph instead of 5, but that's totally fine because it's enough to draw a line that we need to go through. Connect the points by drawing a line through them. And there it is. Pause it, rewind it, slow down if you have to. Going fast. Let's do the same thing for this one. Graph the function x plus 2y equals 8. We can't graph the function until we solve the equation for y. Here's where all that work comes in from what we did before. Minus x from both sides. You're left with 2y equals -x plus 8. Put them in order, the x first, then the 8. And then don't forget we have to divide by 2 once, twice, 3 times. And nobody really likes to see that x over 2 like that as a fraction, or as a division. So we're going to write it as a fraction. Y equals -1/2, put a 1 in front of there, x plus 4. 8 divided by 2 is 4. Okay, take a look at our table over here. Shorten it up a little bit. Because you're just doing that middle part on the calculator, you don't have to write it down every single time. Let's come up with the 5 numbers that we need to put in here. Normally, we would put in -2, -1, 0, 1, and 2. Okay? But we don't want to put those in this time because we have a fraction in front of our x. And we don't want to graph fractions. We don't want to go over 1.5 and up 2.5. So we're going to use any number that's divisible by 2. So over here, we're going to put -4, -2, 0, 2, and 4. Makes more sense. And you still want to do the closest ones to 0. We don't want to use -10 and -8 or 20 and 30 and 40 because they're divisible by 2. Closest ones to 0 so they fit on a graph. Grab a calculator. On your calculator, let me show you this little trick unless you've already figured it out. If you have a calculator like mine, even if it's not pink, you would type in -1 fraction 2 times -4 plus 4. So it looks like this, -1 fraction 2 times -4 plus 4. When you hit equals, you get 6. Okay, that's doable. So we have 6 right here. Now watch this. I don't need to type in -1/2 times -2 plus 4 again. If I already had an answer here, if I just hit the up arrow, go hit your up arrow right here, it retypes, I got a glare, sorry. It retypes the entire equation for you. So all you have to do there is go over to your -4, and this time we don't want a -4, we want a -2. Don't delete the -4, it'll get rid of the space. You're just putting a 2 over the top of it. Hit the 2, -1/2 times -2 plus 4 equals 5. Got it. Do it again. Up arrow. Go over to the -2. This time we got to delete the negative. We don't want the negative in there because we're putting in a 0. No such thing as a -0. -1/2 times 0 plus 4 equals 4. I bet you see the pattern, 6, 5, 4. But let's just double check to make sure. Up arrow. Go over and change this into a 2. We get a 3. Up arrow. Go change this 2 into a 4. And we get 2. As predicted. 6, 5, 4, 3, 2. And now we have our 2 points right here. Our coordinates. Or our 5 points. We don't have to rewrite it as coordinates. We can just look at it as xy, 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 and xy. Go ahead and graph it. Left 4, up 6. Close enough, it fits. Left 2, up 5. 0, up 4. 2, up 3. 4, up 2. Looks good. Take an eyeball at it. Go ahead and throw a line through it. Goes on to infinity. Okay, a little bit different on this time. They do give us a domain, but not so specific of a domain. Graph the function with a given domain, then identify the range of the function. So luckily for us, it's already set up, y equals 4x plus 1. We're going to make our table here and go x and y. And normally, like I said, we do -2, -1, 0, 1, and 2. Not okay. Because it says a domain has to be greater than or equal to 0. We can't use numbers that are smaller than 0. So let's just go with 0, 1, 2, maybe a 3. We'll see if that gets too big. Go ahead and plug it in. 4 times 0 plus 1. 1. 4 times 1 plus 1. 5. 4 times 2 plus 1. 9. This is getting too big. 4 times 3 plus 1. 13. That's not going to fit on the graph. So we go over here and we start at 0, 1, over 0, up 1, over 1, up 5. Good enough. We can fit 2. As long as you can fit 2 points on a graph, you can tell where the graph is going to go. We don't need the 3/13 or the 2 9. Now be careful. Some of you will be tempted to do this and throw your line through that. That's not okay. The domain says we have to stay at 0 and bigger than 0. So when you draw your line, it has to start here and go through this point. You can put an arrow on this end because it can go on infinitely that way. It cannot go backwards. And think of that. There's a lot of times that we're going to use this graph. It makes total sense. If you were saying one pizza costs $5 and then every topping that you got on it or every pizza more costs more money, why would you draw a graph that goes negative? You're not going to get negative amount of pizzas and they're going to give you money back. Okay, so a lot of real life problems do start at 0 and continue on from there. So be careful when you draw it if it's given you a domain. We'll do one more practice like that. I'm going to go through this rather quickly. You can pause it to try to either do it ahead of time and try to beat me to it, or see if you can do it without watching me and then double check your answer. This time it says x is less than or equal to 1. So we can start at 1, but it can't get bigger than 1. So we've got to go down from there. Go ahead and pause it and try it, or just watch me. -2 times 1 plus 1. Put that in. -2 times 0 plus 1. -2 times -1 plus 1. -2 times -2 plus 1. We have a little pattern again. We're going to go over 1, down 1. Over 0, up 1. Left 1, up 3. And left 2, up 5. Double check, make sure they look like they're in a row. And once again, be very careful drawing your line. Your line should start at 1, which is right here. X is positive 1. And it goes this direction. But you are not allowed to draw it in this direction. All right, enough practice with domain. Now we're going to talk about horizontal lines and vertical lines. All horizontal lines, if they go straight across, they only have an equation with a y in it. Horizontal lines do not have an x in it. Because if you think about it, a horizontal line only touches the y-axis. It doesn't go down and touch the x-axis. Vertical lines are x equals only. There's no y in it. So these are much easier to graph. There's not any plugging in to do. You don't have to do a table because it's either straight across or straight up and down. If you look at them on a graph, here's example of x equals -1. Let me get this one out of here for now. Okay, I'll get this one out of the way. Maybe. Okay, if it says x equals -1, makes sense because where is it touching the graph? At x, and x went left 1. Well, so is this -1, -1, -1, -1. The y is changing, but none of the x's are changing. So easier than easy, no tables, no substituting, no plugging anything in, no domains, just straight up and down graph. Okay, let me get that one out of the way. This one says y equals 2. Well, here's y. The graph has to actually touch the y-axis. So we're going to take our, I got it out of here somewhere. We're going to take our line, and it's perfectly straight across horizontal at y equals 2. Makes sense, because here's y, and we go up 1, up 2. Every one of these points is up 2. So if I asked you to do this yourself, y equals -3, pause it, graph it. Okay, you're back. If you wanted y equals -3, here's your y-axis. You went down 3. Down 3, and you draw a line. You still have to draw the line through there. You can't just put a point. All of these points on this line are down 3. Then I'm going to put an A by it so you know which one it is, because that was graph A. X equals 2. Go ahead, try it. Pause it. All right, you're back. We're going x equals 2, which is straight up and down at x equals 2. Do me a favor. Don't make this any harder than it is, okay? Don't overthink it. It's just touching the x at 2, and you draw a line. One last one. If it gives you a domain, y equals 1. We're going to do y equals 1. Don't draw this yet. There's y. Ooh, that's a very crooked y equals 1. Draw it straight as you can. But the domain says x has to be bigger than 0, or it could be exactly equal to 0. So we can't have any of that part of the graph. We have to start it here and go that way. All right, that's it. Good luck with your graphing.